Starting the record. Okay, hi to all again. Today we will learn the main principles of working with Iridium Pro for Modbus driver. The main communication principles between Modbus compatible PLC and Modbus server and Modbus application, Iridium server and Iridium application, i3 Pro. We'll have only 1 hour, so it will be the basics of data transferring, data changing, and we will also see how to make a gateway between different automation systems based on Iridium server. Okay, Iridium Pro. It supports the same things as the previous Iridium versions, so you are able to use SIP intercom, IP cameras, and DVR. You can create the unique interfaces for Windows, iOS, and Android panels and integrate with different automation systems in one application. You are also able to use JavaScript to make some difficult logics and scenarios for your automation systems. But in the new Iridium, you are also able to use Iridium Server. It solves the big problems that we have with the previous Iridium version if we are communicating with Modbus devices. As you know, Modbus protocol is not an event protocol. It means you have to ask the PLC to know any changes. So if you have big number of control panels, iPads, PCs, and tablets, for example, your PLC is overloaded. For example, the basic PLC based on Modbus, for example, Vago, supports not more than 5 simultaneous connections with control panels. It is not so big for a big house, so Iridium Server works like a gateway between control panels and your PLC. It makes you able to control your automation systems with big number of control panels. It makes you able to store the logics that have to work 24/7, and you can make mathematical actions on server between send the data to control panel, and we will learn how to do it and how to start with Iridium Pro with the new version of Iridium. Let's start from the basic things, how Iridium communicates with the PLCs. First of all, you can control your automation systems without Iridium server, just directly from your application on mobile device. Via the local network, you can connect to PLC, send the data and receive the feedbacks. But if you have big number of control panels, it is a problem because you have to send the request of current PLC status from each panel to each PLC. So it's overloading your device. The next point is using Iridium server. If you are able to install some hardware or software version of this server, you are able to control your installation from big number of devices, but server communicates with PLC directly, so you need only one connection for each PLC. It is not overloading devices, and all the devices are synchronized between them and between PLC and control panel. You have real-time data. Iridium server can be installed on different devices. You can learn more about it on YouTube. We have big instructions, big information about different type of servers on our support portal. So please take a note that the server helps Modbus users to solve the main problems of Modbus communication. Okay, let's start with practice. And the first point will be, what if you had a visualization project in the previous Iridium version, in Iridium V2? For example, I'll take No, I'll take a version project from previous Iridium version, and I'll try to open it in Iridium Studio application. It is the same as Iridium Gui Editor, but it makes you able to set up Iridium server also. You can see that Iridium asking you to convert the project, and you are able to do it with one click. And now this project are able to work with i3 Pro application directly with your PLC. If it is enough for you, okay, good. So you can just start the emulator and try to communicate with your PLC. I'll start the simulator of Modbus PLC on my PC. And we just look at communication. Then, if it is not enough for you to use only visualization app, if you want to use a Iridium server, you don't need to start your project from zero. You can convert the visualization project to server project. It means we are generating the new project based on the visualization. You can see in the right mouse button the tab Create Server Project. I push on this button, and now you see the project divided on the two parts. The first part is visualization. Now you see Iridium server driver instead of Modbus driver here. It means visualization will communicate with server, like you see on this image. Here is visualization, here is the server, and now we are communicating with server. So you can see the driver of server in your project. In the second part, you can see the server project. Now the Modbus driver is here. It is this part of communication between server and PLC. We are adding the host of your PLC and connection parameters right on server. And at the left part of server project, you can see the list of virtual variables. Your control panel will communicate with these variables, not with the driver directly. So, if we are communicating with virtual variables, it means we don't need to ask the PLC each time. We're just asking for server. And server says what is the current status of your equipment. We are saving project, and then we will be ready to send it to Iridium server. For example, on Windows, Iridium server is a console application. It looks like this, and with the Send to Transfer button, I can transfer this project to the server. I'll show you the transfer application a little later. Here you see the transferring process. And now the project started, and with W button I can open the web interface of server. Before you see this screen, you have to authorize on server with your login and password from Iridium mobile website. In the Channels and Feedbacks tab, you can see the current status of each register of your Modbus device. I'm connected to the virtual PLC, so you can see all the changes in the web interface in the real time. Let me show. You see, I changed the register in the simulator, and it is changed in the web interface. It is a great tool for the beginning when you are trying to know what is working fine and what is not with the registers. And then you can connect to the server your control panel. It is easy to start the control panel via the emulator. I just need to add the IP address of my PC where the server started. You can see the parameters of the server here. You can preset the address of Iridium server, the port, login, password, and so on. We are going back to the visualization project. I just need the host and port. And then you see we are connected to Iridium server. I can change the variables and I can see these changes in the web interface in real time. You can see it in the right part of the web interface. So in a few minutes, we made a direct connection between the visualization panel and PLC by Iridium server. It's just a direct transferring of data through the server, but it makes you able to connect the server big number of visualization panel. It makes you able to decrease the loading of your PLC. And the next step is, if you didn't have a ready project in the previous Iridium version, if you want to start from zero, what should you do? The easiest way to start the learning of Iridium is using of ready interfaces. On our website, in downloading section, you can find big number of ready templates of visual interfaces. For example, the project with a great structure for beginners called iOS style. It's a Russian website. I'll switch to English. The easiest GUI for beginners is iOS style for smart home. Please download it to your PC and start to learn Iridium with it. I'll open it on my PC to show you how to start making structure of visualization project. Academy. For example, I'm opening the ready interface for iPad, iPhone, or any other tablet with a small resolution. We also have templates with a bigger resolution for Retina displays. It is opened, and here you see the structure of folders. You don't need this folder. Just open home rooms and add the rooms of your own. Add the names of your own rooms in your automation object. For example, let's start with working room. Oh, sorry. This button opens the room that consists of two parts, left part and right part. Left part makes you able to open some audio video control, and right part makes you able to control engineering systems. When we start this project, these two parts will look at the same page. You'll see this in a few seconds. Let me show. Working room, I'm opening, and you see the left pop-up and right pop-up as the same page. You can control some objects on it. In the GUI editor, you can remove control objects that you don't want to see and add in additional objects. If you have more than 5 audio-video devices in room, or you want to create some additional device, for example, if you want to see the video from camera, you can add an additional button. And in Programming tab, you have to say what pop-up should be showed when you press this button. For example, I can clone some of pop-ups and call it room 1 camera. Later, you can see the instructions that shows you how to show the IP camera in your web interface or in your GUI interface. But now I'll just add some field that will make you able to see that something changed. Okay, with button camera, I'm open pop-up room 1 camera. It is done. Working room opens the list of control devices in this room, and I'll show you that these simple actions make you able to open the new tab in this room. We are in room, press on button camera, and we are in camera. Then we press back and back again, and we are at the home page. You see, it is easy. Then you may see that there is only 2 rooms, but what if you have 20 or 30 or 200 rooms? It doesn't mean that you have to copy each room one by one. You can just clone this folder with this button to receive one more list of ready preset rooms. Then you should rename this folder to be sure that you made everything fine. You are renaming all the pop-ups to be sure that you added all the needed pages. And for example, if in this room you don't have audio-video equipment, you can just remove any additional pages and remove any additional buttons from this room. So this room will contain only control of engineering systems and some scenarios that you can make as you wish. In the group actions, you can preset the list of controlled lights in all the home or on the floor. You can control all the climate from one page. You can see all the cameras in one page and other. These system pages changed to make a logic work. So we have a ready interface. Then we have to add in this interface the list of Modbus registers. The list of Modbus registers could be big, and we don't have a specified system of import for some different PLCs, for some different controllers, but we can import the list of registers from Excel, from CSV files. These files look like this, and you can easily preset the list of registers with a ready template. How to preset the registers you can read in our support portal for developers, dev.iridiummobile.net. We just go into import section, and now you see the template for downloading, file for downloading. You will open it in Excel or in Google tables, and then you will change it as you wish. So creating of big number of different registers will not take really many time. It will take just half an hour maybe if it's hundreds of variables. Then you have to open Project Device Panel in Iridium Studio and import this CSV file from the folder where you saved it. We are adding Modbus driver. So 205 channels, registers imported in our project. In this situation, it's a holding registers, but it could be holding and coil registers and anything else. Then we are going to room activities, and drag and drop registers to control buttons. And it just works. You can also drag some big number of commands at the same button to make a simple scenario. But I recommend you to add the delays between commands in scenario. You don't need a feedback channel. You can double click on item to see the list of commands related with this item. If we add a delay between these commands, for example, 50 milliseconds, we'll be sure that all the commands delivered this how the scenario looks. Then, when you're ready to test it, you can just start emulator. And see that the registers changes when I press buttons. You can see it here. It is really small items because it's just a simulator. You see when I'm switching register on PLC simulator, the same action showed in your visualization interface. The question from Adi: why delay between commands? Not all the PLCs are able to receive commands without delay. I'm faced with problems when we send the commands without any delay. Iridium sent them really fast, and PLC see one command and don't see another one. Just too small delay can be not okay for your PLC. With the PLC simulator, you can see it is fine. All the registers changed, but with real equipment, it is not okay. Okay, when you're done the project, you can think, okay, fine, but my PLC does not support so many connections as I need. For example, you need 10 control panels, smartphone of your customers, tablets on the walls, and PC on the desktop on your table. So you need a server. When your project is done, when the visual part of project is done, you can create the server project with one click, as in the previous case. Just press Create Server Project, and it is ready All the relations will be saved. All the buttons will still work, but now we will work via the server as a gateway. You can see our 200 of channels here, and you can see Iridium server driver here. Commands in our room is still there, but it is command to Iridium server, not to Modbus. So it is easy to do, and we have more capabilities of working with JavaScript on server. For example, if your PLC is not floats, you can send integer value and then convert it on server and send to all the control panels. It is really easy to do. I'll show you how. Please open the support portal dev.iridiummobile.net. Open server menu, server project, and you will see the article. You will see the article data modification on the server. That's what we need to know for efficient modifying of Modbus data on server. It's a unique functions that available on the server part of your projects that makes you able to create only one script functions for different Modbus channels that is making some mass operations with the data from PLC. I'll show you the function modifier. It's called function modifier. It consists of unique name and input data. Type of channel, it could be command or feedback. Name of channel that was changed. And the new value. So, if the function modifier related with some command or feedback on server, you can relate the modifying function here. I'll show you at the ready example. Here you can see the modifying function related with the feedback of Modbus driver. Inside of this modifying function, you can see some list of actions. It could be mass dividing or multiplying. It could be gatewaying from Modbus to another automation system. It could be some additional events that should be created on server if the channel changed. Anyway, we are relating some script function with some feedback of Modbus driver, and what we can do with it. We can, for example, divide it to 100 and then return the value to feedback channel. How it looks for end user. Let's see some sample. For example, modifying function F2 in this sample makes the following. It is dividing the value to 100 and then returns to feedback channel. We are sending the server project started. Here it is. The project started and we can open the web interface with W. Then we go to channels and feedbacks and we can see the real value of channels. Let's see the channel with name 6 related with modifying function f2. So the result of changing of this feedback should be divided to 100. And how it looks for end user. Let's filter the channels. We'll first find the channel 6. Okay, here it is. I am sending to Modbus the value 1000. I turned off PLC. Sorry. I set the value 1000 again. And as a result of this action, you see 10, not 1000, but 10, because result that is stored on PLC divided in script to 100. So you see we sent from Iridium 1000, we see 1000 on PLC, but your control panel will see 10. How it could be used? For example, if your PLC do not support float values, you can send the temperature 22 degrees of Celsius as 2200. And you will see on control panel 22 degrees of Celsius. So you are able to send the data with some numbers after the dot. You can also see the current value on graphic, but it's a next step. I'll show you how to save the status of some variable in database. For example, if you want to store some temperature value or the current state of equipment in Iridium database, at this SQLite database, you have to turn on the storing property, DB save strategy. You have to set deadband or interval, and of course you have to turn on storing in database option of feedback channel of driver. For example, we can store in database some channel of Modbus driver. We store the value like a signed 32-bit with deadband 1. If the value changed more than 1, the new value will be stored in the database. You can also use an interval, for example, to store the value each second or each minute or each hour, for example, as you wish. And all these graphics will be available in the web interface. For example, let's search for, I forget the name of this channel. I have added the virtual channel, graph 1, and in this simple script, I'm making an incrementation of this value for each second to show you how it looks like we see some graphic, some real data on graphic. Graph 1. Here it is. You see it increases each second, and on the graphic it looks like this. It's data for a long time. So we can see when the server was turned on and off and on again. It is easy to see this data on the web interface, but you can also display this data on control panel to show this data for your end user, for your customer. I'm making the linear trend field in the visual interface see the type of item linear trend. And now I just have to drag and drop the channel on this graph. I'll restart the server to make you able to see the result with default settings of graphic. We start the emulator, and you see how the current value change on this graphic. Of course, you can change all the settings of this visual item. You see the increases value after starting off server. Okay, and the next step. The next capability of Iridium server is you can transfer the data between different automation systems. You can easily transfer the data without some physical gateway. For example, you are able to send the data from KNX to Modbus with a physical gateway, but it could be too expensive and it makes some limits of usage, so maybe it will be easy to use Iridium server for data gateway. For this, we are also using modifying functions. Modifying functions that is related with some feedbacks of Modbus driver, for example. Here you see the script modifier from Modbus to KNX. What does it make? It is receiving the data from Modbus register, modifying this data and send to KNX system. You can see the KNX driver at the bottom of the project. What should we do to make it work? We have to make the same names for Modbus feedbacks and KNX commands to make the gateway between these different systems with a simple steps, with a simple script. I'll show you the script. Here is how it looks. You see the same structure of modifying function, unique name of function, input parameters, type, name, and changed value. Then I'm splitting the name of changed feedback with dot. Each name of server variable consists of several parts. For example, server, channels, KNX, 0. It is divided by dot. So with split method, I am separating the name of channel received from Modbus, and then I am searching for channel with the same name in KNX system. So if the channel with the name 0 changed in Modbus, I am searching for command with the name 0 in KNX. And if it is found, I am just resending the received from Modbus value to KNX. Easy? Yes, it is. And what should we do to add this gateway for big number of channels? I just have to go to the properties of each channel I want to gateway, and I should add the modifying function from Modbus to KNX, from Modbus to KNX, from Modbus to KNX. You can also add the names of channels you want to resend from Modbus to KNX. Just in this script, you can make it more difficult, you can make it more complicated, but it will be the same generally. You're just resending the data between systems all the time when the server works. Question from Adi. Could we use reverse? Let's say from KNX to Modbus. Of course, it will work the same way. You can see the same function that makes the same from KNX to Modbus. I'll add it at bottom. Here you can see the function with name from KNX to Modbus. I am searching for name of channel that was changed. I am see the same command in Modbus driver. Just add the name of driver in this inside of this function to make a gateway to this driver. And if the channels called with the same name, it will work. You will be able to transfer from KNX to Modbus. So you are searching for feedback in KNX driver, adding the function from KNX to Modbus, and then this value received from KNX will be automatically sent to command 0 in Modbus driver. If the data sizes in Modbus and KNX is not the same, if you received the value in the range, for example, 0 to 125, and if you want to change it to 0 100, for example, you have 225 in KNX and you have 100 in Modbus, and you want to resend the data from KNX to Modbus, you have to modify the received value on the road. How to do it? It will be also easy to do. I'm multiplying the received value to 225 and divide it to 100, and then I have to, I forget the word, sorry. I have to make the integer value from this formula. I'm using method to fixed 0 without dot, without any symbols after the dot. So I'll send the integer value to Modbus from KNX, and this value will be converted from 0 to 125 to 0 100. It is really easy to understand what's happening here. It is really easy to drag and drop I lost my thought. And okay, it is really easy to choose the channels, the feedback channels that you want to transfer. And you always see what exactly you are transferring. And the last sample of data modifying on server is using of global listener. Global listener is a new function of Iridium Pro. It makes you able to subscribe. To any feedback or any tag of your project. For example, you can subscribe virtual channels, driver tags, driver tokens, project tokens, system variables. For example, here you can see the subscribed channels, virtual channels of server, driver tags, online status of driver, and you can subscribe to times, minutes. If you remember the previous Iridium version, you may know that in previous version you was able to subscribe only the separated drivers, or you had no chance to subscribe to changing of some system variable. But now you can listen for any changes in the project. For example, if I am creating the virtual channel or virtual tag on server, it is not available on the side of equipment. It is internal variables of server. To these variables, you can send the data from control panel. For example, you can write the value on control panel and it will be stored on server. In the server text, you will be able to store the data with JavaScript. For example, if somebody changing some value on server, you can say inform on the control panels that the value has been changed with this control panel. So you can make the communication between different control panels via the server. You can synchronize the data on all the control panels without using of equipment variables. It is really great if you need some complicated logic for each panel and you don't have some logic variables of your PLC. With the Modbus, yes, we have possibility to store the data on PLC, but it is always better to skip some additional steps. So you can make a script on server that makes you able to work with internal server variables without an additional equipment with your own scripts. And subscription, for example, make you able to see that the channel of server has been changed from control panel. If it happened, you can, for example, turn on some equipment channels. You can make a difficult scenarios here. So it makes you able to drag and drop only one command to the graphic item in your GUI. And this single command, scenario 1, will start the big scenario. For example, it could be scenario for 24 hours. So your control panel will not stop work if you are turning it off, because the long time scenarios will be made on Iridium server. Okay, so if you are starting with Iridium version 3, it is better to start from visual interface, I think. But you have to remember that you are always able to convert your project to panel path and the server, and it will work good and fast. For example, you can install Iridium server on your own desktop PC, or you can buy mini PC like Intel NUC with Linux or Windows, and it will work properly. You can also use the hardware version of Iridium server, for example, a logic machine with some physical interfaces, and you will be able to use these physical interfaces to communicate with equipment without IP connection. So that's all that I wanted to show you today. If you have any questions, please ask. And the last important detail, when you're ready to share the project with your customer, you have to download the project in Iridium Cloud. If you didn't face with Iridium Cloud for new Iridium version, I can see some easy sample at the English site. Okay, Iridium Cloud consists of projects, licenses, and invited users. In the project tab, you have to upload projects, all the projects for control panels and all the projects for Iridium server. Then you have to activate a trial period it is for free, or you can buy the commercial license. And then you have to invite the users that will be able to see the projects. I'm choosing the projects, and I am able to create an account for end user if you want. So the account created, the user invited, and now I will be able to see these projects in i3 Pro application with a commercial license. On the server, you have to log in with your integrator's account. You are downloading the server project, and it works with commercial license also. Question from Mikhail. I must have Iridium server in installation. You can use it or not. For example, in this sample of visualization project, it works via the server, but it could also work directly with the PLC. If you need just one control panel, it's not needed to use the Iridium server. Or if you don't have any scenarios, if you don't have any 24/7 processes, you don't need the server. You can connect to PLC directly via Modbus TCP. If your PLC do not support Modbus TCP, if it is RTU or ASCII only, you can install some physical gateway from Modbus TCP to RTU and connect to it via Modbus TCP anyway. So it could work directly, like here, or you can work via the server with some profits. If you worked directly, in any moment you are able to choose the server, and it will be easy to convert the project. Okay, if there is no more questions, we'll start the record. Thank you. See you at the next webinar.